Our next chapter in class is going to focus on fractions. So this first section is just an introduction to fractions and mixed numbers. And unfortunately for our first topic, we do have quite a few definitions. So these are things that you need to know and you need to understand. So let's get started. So first of all, we have that fractions represent part of a whole or division of quantities. Okay, so we've already seen that. We've seen how we can represent division in several ways. So we could represent division like 12 divided by 3. We could represent division 12 divided by 3. But even better, we could represent division as 12 divided by 3. So this right here is a fraction. It is a way to represent division of two quantities, okay? So fractions, again, a way to represent part of a whole. It also represents division of quantities. Now, when it comes to a fraction, there are two distinct parts. There's a top number and there's a bottom number. And when we're talking about fractions, the numerator is the top number in the fraction and indicates the number of parts being considered. So let's go ahead and start highlighting a few things. So we know what a fraction is, and now we know that the numerator is the top number. And more importantly, it indicates the number of parts being considered. So remember, one of the definitions of a fraction is it's a way to represent part of a whole. So a whole being this whole entire thing, and we're going to break it into a certain number of pieces. How many are we considering? That's the numerator. Now for the denominator is the bottom number in a fraction and shows the total number of equal parts. So let's think about what that means. So I'm going to go ahead and say denominator is the bottom. So let's consider the fraction 3/4. 3 is the numerator, 4 is the denominator. So what we need to understand is when we're talking about a fraction, we're talking about one whole thing, and we're going to split that whole thing into equal parts. The denominator tells us what those equal parts are. So this tells me I'm considering this one whole thing that's broken into 4 equal parts. The numerator, which is 3, says I'm only considering 3 of those equal parts. So imagine a pizza. So we have our pizza right here. We've got crust. We've got pepperonis. Now imagine we took that pizza and we split it into 4 equal size slices. And let's say you ate 3 of them. That would be you eating 3/4 of the pizza. So that's exactly what fractions do. They take this one whole thing, break it into a certain number of equal size pieces, and the numerator tells us how many of those pieces we're considering. Okay, so a bit more about the numerator and denominator. The numerator and denominator are separated by what's called a fraction bar. So this right here, this is the fraction bar, and we already know that it really just means divide, okay? But we can call it officially a fraction bar. And then in the example, the fraction 7/8, 7 is the numerator, 8 is the denominator, okay? Now, even further, when it comes to fractions, there are two types of fractions and then another alternate form that we always look at. So types of fractions, this is really important, and you do need to understand these definitions and understand the differences here. So first up, we have a proper fraction, okay? A proper fraction is a situation where the numerator is always less than the denominator. So it kind of truly is part of a single whole, okay? So the numerator is less than the denominator, and when you have a situation like that, the total value of that fraction is always less than 1. You have less than one whole thing, less than one whole pizza, okay? An example of a proper fraction would be something like 5/9, and we know it's a proper fraction because the numerator 5 is less than the denominator 9, okay? So I'm going to go ahead and highlight this too so you can understand an example of a proper fraction, okay? Now, next up, we have an improper fraction, okay? Now, an improper fraction is a fraction where the numerator is greater than or equal to the denominator. So in this case, you have one whole, that's where the numerator is exactly the denominator, or you have more than a whole, that's where the numerator is more than the denominator, okay? So when you're talking about improper fractions, they have a value of 1 or more, okay? So proper fractions, they have a value of 1 or more, and we have examples. The first example I have here is 4/3. So 4/3 would be considered an improper fraction because the numerator 4 is greater than the denominator 3. So we have more than one whole thing. If we were talking about 4/3 of a pizza, that's more than one whole pizza. The other option or the other example we have here is 2/2. Okay, 2 over 2 is still a fraction. We're representing some part of a whole. We're also representing some kind of division of quantities. And this is considered improper because in this case, the numerator is exactly equal to the denominator. So if we're looking at 2 halves of a pizza, we have that one whole pizza. Okay. Now, the third version that we're going to look at is called a mixed number. And what's really, really important about a mixed number is it is another form of an improper fraction. So I do want to highlight that. A mixed number is another form of an improper fraction. Okay, and that's going to become something we learn. We're going to learn how to convert between the two at some point. So when you're talking about a mixed number is a number that combines a whole number and a proper fraction. Okay, so if you have some whole number and you kind of add a proper fraction to it, you've created what's called a mixed number. And mixed numbers always have some kind of improper equivalent. Okay, so when you're dealing with mixed numbers, they always have a value of more than one. And an example would be something like 3.5. So that's 3 wholes plus half of another. Okay, so 3.5 is an example of a mixed number. And just know mixed numbers and improper fractions can represent the same value. You can always convert between those two. Okay, so finally, let's look at some examples. So for example 1, it says write a fraction or mixed number for each situation. So for part A, it says Johnny ate 3 out of 8 slices of pizza. Okay, so we have this one pizza. It's split into 8 equal size slices, excuse me. So we have one pizza split into 8 equal size slices. Johnny took 3 of those. What fraction of the pizza did Johnny eat? Well, Johnny ate 3/8 of the pizza. Now, just for fun, how much pizza is left over? Well, if the pizza was split into 8 equal size slices and Johnny ate 3 of them, that means 8 minus 3 slices are still left. So that would tell me that 5/8 of the pizza is still left over. Now, that was not part of this question. That was just extra for fun. All right, part B. Pam bought 5 1/3 meters of fabric. So Pam is going to be sewing some outfit, whatever, curtains. I don't know. I don't know what you can make out of 5 1/3 yards or meters of fabric, but we need to find a number that would represent this. Well, Pam has 5 whole meters of fabric plus 1/3 more. So 5 1/3 in this case. Okay. So example 2. Still dealing with fractions. Example 2 says reviewing division properties of 1 and 0. So this is stuff that we actually talked about 2 chapters ago. We just need to make sure we kind of bring it back to the surface. Anytime you're dealing with division or fractions, there are certain things that you really, really do need to know. So the first division property of 1 says if you take a number and divide it by itself, you just get 1. So if I were to take 7 and divide it by 7, I just get 1. That's 1 whole. 7/7 is 1 whole. So in part A, we're kind of doing a play on that, but we're also throwing in some negatives. So if I have 9 divided by 9, we already know from one of the division properties of 1 that that has to equal 1. But now one of those two values, one of the two parts of the fraction is negative. That makes the whole thing negative. So remember, it's kind of like if you take a positive and divide it by a negative, you get a negative. So here, the quotient would be -1. Now, the other part to the division properties of 1 is if you take a number and you divide it by 1, you always get the number you started with. So if I take 9 and I divide it by 1, I just get 9, okay? But in this case, we have -9 over -1. Well, anytime you have a fraction where both parts of the fraction are negative, you have to always remember those division rules for negatives. If you're dividing two numbers that have the same sign, the result is positive. So this right here simplifies to +1, okay? Now, when it comes to the division properties of 0, these are the two that get students confused probably the most often. So when you're thinking of a fraction, think about where the 0 is. If you have a situation where you have a number divided by 0, think of this as no way. Can't happen. You cannot divide by 0. It's illegal. It doesn't work. It's undefined, okay? If you have 0 divided by a number, think of this as okay. So that's one way to remember. If the numerator is a number and the denominator is a zero, that reads as no, so no way. If the numerator is a zero and the denominator is a number, that reads as like okay, so that one works. So looking at part C, we have 0 divided by a number. That one's okay. If you replace that number with some number k, everything works out, everything's good. This one truly equals 0, okay? Now, if you were to look at part D, we have 9 divided by a number. So if we replace 9 with an n, that one would read, no way, this one can't happen. This is the one that is undefined. So make sure you understand all 4 of these properties, the 2 properties of division in 1, the 2 properties of division in 0, but it's usually part C and D that gives students the most grief, so make sure you understand those. All right, finally for this video, we have example 3, short answer. Think of this as applications, whatever you want to call it. So part A says, of the 14,146 McDonald's restaurants in the United States, 1,233 are in California. What fraction of the McDonald's restaurants in the US are in California? Well, we know 1,233 are in California out of the total 14,146. So this is the McDonald's in California. Now, just for fun, excuse me, about to choke half to death. For fun, what fraction are not in California? Well, we can do a little tiny bit of arithmetic and figure out what fraction of the McDonald's are elsewhere, okay? So we know there's 14,146 McDonald's total. We know of those 14,146, 1,233 are in California. If we subtract the 1,233 from the 14,146, that tells us how many of those McDonald's restaurants are in all other states in the US. So let's see, we're going to do some subtraction. So 6 minus 3 is 3. 4 minus 3 is 1. I can't take 2 from 1. Need to borrow. 4 becomes a 3. 1 becomes 11. 11 minus 2 is 9. 3 minus 1 is 2. Nothing to take away from 1, so I drop it down. So I would say 12,913 out of 14,146. So even though that's a wild looking fraction with some really, really big numbers, that represents the number of McDonald's not in California, in the United States alone. All right, let's look at part B. So of the 50 states in the US, 31 have national parks. What fraction of the states do not have national parks? Read these questions carefully. So the ones that do have national parks, that's easy. We know there are 50 states, and we're told flat out 31 of the states have national parks. But we want to know what fraction don't have national parks. So we're going to put no national parks. Well, we got to do a little bit of work there. So we know of the 50 states, 31 have parks, so how many don't? Well, I can't take 1 from 0. I do need to subtract here, but I can't take 1 from 0. So 5 becomes 4, 0 becomes 10. 10 minus 1 is 9. 4 minus 3 is 1. So that tells me 19 states don't have a national park. So now let's write that as a fraction. So we would say 19 out of 50 states have no national park. So there you have it. Okay, so that's it. That's just a general understanding of fractions. In the next video, we're going to look at kind of visualizing fractions. And then in the future videos, the future sections, we're going to look at adding fractions, subtracting fractions, multiplying fractions, dividing fractions, simplifying fractions, order of operations with fractions. So there's a lot to come still.